Okay, so let's look at this example of a problem involving reaction mechanisms. So in this question, they gave you three steps of the mechanisms and they ask a series of questions. The first of which is determine the overall reaction. And this is something that we have done before. We did one like this where we simply add up all the elementary steps, canceling out the identical items on both sides, and that will give us the net reaction. And that's what I've done here previously. So what I did was basically rewrite all these steps over here, right? And all I did was cancel out the intermediates, which in this case would be the N2O2 here and here, the N2O here and here, and I basically add up everything else on both sides, and this is the equation which represents the overall reaction. All right, so that's the A part. The B part is asking, are there any intermediates in this reaction? And the answer, of course, is yes, because we canceled them out in order to get the overall equation. So we cancel out the N2O2 here and here. We cancel out the N2O here and here. So therefore, B, the answer for B would be that these would be the intermediates of the reaction. Now let's get to the more complicated part of this problem. C, determine the rate law. So basically, and it says the intermediates may not appear in the rate law, right? So let me go to the full screen mode here and choose my ink here. Okay, so how are we going to do this? Well, first thing I'm going to do is write down the rate law based on the rate determining step, because remember it says here that the rate determining step is the second step, right? So that affects the overall rate of the reaction. So I'm going to write down here that the rate is equal to K times the concentration of N2O2 times the concentration of H2. All right. Now here's the thing: the overall rate reaction, the overall rate law should not contain any intermediate, right? It only contains the reactants involved in the overall reaction. And as we said before, the reactants in the overall reaction would be the NO and the H2, right? So what we have to do is find some way of expressing the intermediate here in terms of a reactant. And the answer lies in this step here, right? Now, what I'm going to do here, I'm going to designate the rate constants for the different steps based on me having the same set of reactions here rewritten on this side. So K1 here, oh, and another thing I need to mention, you'll notice that this reaction here is a reversible reaction. It goes in both directions, right? So you have the reaction going in one direction as well as the other direction for the first step. So for the forward reaction in the first step, the rate constant for that would be K1. For the forward reaction for the reverse reaction in the first step, I'm going to call that K minus 1, right? And then for the second reaction, the rate constant is K2. And for the third reaction, the rate constant is K3, all right? So those are the rate constants for the different steps. So for the rate law for the second step, the actual rate law would be rate is equal to K2 times the concentration of N2O2 times the concentration of H2, right? And as I was saying before, we need to find some expression to replace the N2O2 so that is expressed in terms of the concentration of the reactants. And the key to that lies in the first step here, right? In the first step here is a reversible reaction. Now, the assumption that we're going to make here is that the rate of the forward reaction is equal to the rate of the reverse reaction. So therefore, we can write down that the rate of the forward reaction, which is equal to K1 times the concentration of NO squared, is equal to the rate of the reverse reaction, which is K minus 1 times the concentration of N2 over 2, right? And then what I'm going to do is solve for the concentration of N2O2 equals to K1 over K minus 1 times the concentration of NO squared, all right? And then what I'm going to do is plug in all of this here into where we have the concentration of N2O2. So when we do that, we're going to end up with rate is equal to K2 times K1 over K minus 1 times the concentration of N2O2 times the concentration of H2. All right, and what we can do, since this here, we have a collection of constants here, we can simply replace that with K times concentration of N. Oh, by the way, I'm sorry, this here should be replaced by NO squared. So this should be concentration of NO squared. My fault. Okay, let me scratch this out. So therefore we can, as I said before, replace all these constants here with one constant K, and that would be equal to the concentration of NO squared times the concentration of H2. And this, ladies and gentlemen, would be the rate law for this reaction based on this mechanism. All right? So that's basically how you would do part C. And then in part D, very simple, the total order, let me do that over here. Total order would be the sum of the two orders in the equation, which would be 2 plus 1 equals 3. And the question is also asking what is the molecularity of the rate determining step. The rate determining step have two reactants, the H2 and the N2. So therefore, the molecularity of second step equal to 2. Okay, so that's basically how we do this particular problem. All right. Okay. One more video and then that will be the end of this chapter. Until next time.